Module 4, Lesson 8, we're going to replace numbers with letters, and it's an extension of Lesson 7. So we're first of all looking at a group of statements. 4 plus 0 equals 4. 4 times 1 equals 4. 4 divided by 1 equals 4. 4 times 0 equals 4, or equals 0, and 1 divided by 4 is the same as 1/4. How many of these statements are true? They are all true. And there are very important concepts regarding identities, zeros, and actually just plain old division. How many of those statements would be true if the number 4 was replaced with the number 7 in each of the number sentences? 7 plus 0 equals 7. 7 times 1 equals 7. 7 divided by 1 equals 7. 7 times 0 equals 0. 1 divided by 7 equals 1/7. They would all still be true. Would the number sentences be true if we were to replace the number 4 with any other number? And my answer, and hopefully your answer, is absolutely. Still be true. No matter what number you replace with 4, those number sentences would always be true. Now we have one interesting side note. If we replace the number 4 with the number 0, let's go back and look at them. 0 plus 0 equals 0. 0 times 1 is 0. 4 divided by 0, or I'm sorry, 0 divided by 1 equals 0. 0 times 0 is 0. 1 divided by 0 equals 1/0, 1 over 0. Now, everything else seemed to check out pretty nicely, but 1 divided by 0 equals 1 over 0 doesn't make any sense. So we want to say the last statement would not be true. Because you can't take something and divide it into 0 groups. Because no matter what, you're going to have one group. Even if you have just one little item, you can't divide it into 0 groups because you still have one item. So you still have one group. That's why division by 0 is undefined. It does not exist. You can't do it. Because if you have something, you're always going to have at least one group. If we replace the number 4 with a letter G, we're going to write all 4 expressions the first 4 anyway, replacing 4 with G. So we would have G plus 0 equals G. Then we would have G times 1 equals G. Then we have G divided by 1 and so we look at them. G plus 0 equals G, whatever G is. G times 1 will always equal G. G divided by 1 will always equal G. And G times 0 will always equal 0. Then we have 1 divided by g equals 1 over g as a fraction. Are they all true except for when g is equal to 0 when dividing? And yes, they absolutely are. So when we write a rule in regards to this particular problem, we want to make sure that we say except for when g is equal to 0, because it is not defined. The additive identity property of 0 says that if you add 0 to any number, you will still have that same number. It seemed really basic when we first learned it in elementary school, but now we're going to put it to better use in this module. Can we replace g with any number? Absolutely. Yes. G can be replaced with any number. Choose a value for g and replace g with that number in the number sentence. And what we observe is, let's choose 100. 100 plus 0 is equal to 100. And you're asked to repeat the process several times, each time choosing a different number for g to prove to yourself that it is indeed an identity property. If you add 0 to any number, you will still have that number. Is it true for all values of g? Yes. Now, the mathematical language for that property we would write g plus 0 equals g. And that is the additive identity property of 0, which states that any number added to 0 equals itself. Next, we'll look at the multiplicative identity property of 1, which says that g times 1 equals g. Remember, a letter in a mathematical expression represents a number. Can we replace g with any number? Okay, and of course we know that we can. We're going to prove that by choosing a value for g and replace g with that number in the number sentence. Again, I'll choose 100. 100 times 1 equals 100. True? Yes. Is it true for all values of g? You can experiment with a number of different values before you say for sure. And then the mathematical language for the property, which is g times 1 equals g. It is again called the multiplicative identity property of 1, which says that any number multiplied by 1 equals itself. Identity, the word identity means staying the same. Okay, a little review of the commutative property of addition and multiplication. 3 plus 4 is equal to 4 plus 3. Commutative property says that you can change the order of the numbers if you are adding, and the answer will be the same. The commutative property also applies to multiplication, so if we multiply in any order, the answer will still be the same. Then we're looking at repeated addition, 3 plus 3 plus 3 plus 3, and rewriting it as multiplication. And we're also looking at 3 divided by 4 written as a fraction as well, just a different way to write division. They ask us then to replace the 3 in each of the equations with the letter A. So what we would have is A plus 4 equals 4 plus A. And then the next one, A times 4 equals 4 times A. And the next one, A plus A plus A plus A equals 4 times A, or 4A. And finally, A, whoops, A divided by 4 equals A over 4 as a fraction. Then you can substitute any number for A. Remember that when you substitute any number, it has to remain the same number for each occurrence of A. And prove that it works for each of those equations. And finally, our mathematical language for this property A plus B equals B plus A. And A times B equals B times A. These are the commutative property. The first one is of addition. Order does not matter when adding. And the second one is the commutative property of multiplication, which states that order does not matter when multiplying.